Solving systems by substitution. So there's a couple of steps you want to make sure you follow. You want to make sure that you have looked at your system and you want to find the variable that is most easily isolated. So decide which variable is easily isolated. All right, and then you are going to substitute that variable into the other equation.
Since we're reading,
my son thinks that yelling is what works best on Zoom, I guess. So substitute that variable into the other equation. All right. Okay, so let's take a look at an example. Let's do something like, let's do an easy one to start with. So we're going to solve by substitution. So you want to be able to do both of these techniques that we're going to, or actually all three of these techniques we're doing. First was the graphing. This is substitution. Let's see. We'll call this y equals 3x and 2x minus y equals 2. So first of all, we need to decide which variable is easily isolated. So it looks like the y equals 3x is already done for us, so we don't have to isolate anything. So then we're going to substitute that variable into the other equation. So we're going to take this y and plug this stuff here in for that. So 2x minus, use parentheses, minus 3x equals 2. There's a reason I said to use parentheses, because if this was a binomial, you'd have to distribute. So 2x minus 3x is negative x equals 2, or x equals negative 2. So then step 3, you're going to substitute back into the first equation. So we're going to take this x equals negative 2 and substitute it back into our first equation. So y equals, actually we could do either one. Do the easy one though. Y equals 3 times negative 2, so y equals negative 6. So this is an ordered pair that tells us that these two lines will intersect at negative 2, negative 6. So that's your solution. All right, so let's try another one. Let's try something like, let's call it example B. X minus 3y equals 13 and 5x plus 3y equals 2. So first we need to decide which variable we're going to isolate. And I think you would probably agree with me, this x is our winner here. So we will add 3y to both sides. So x equals 3y plus 13. Then we can go ahead and replace this x with this expression 5 times, use parentheses, 3y plus 13 plus 3y equals 2. Distribute. 15y plus, oh my goodness, mental math, that's 65 plus 3y equals 2. 18y plus 65 equals 2. Subtract 65, so 18y equals negative 63, and divide by 18. So y equals 18 times 18 times what is equal to 63? Oh no. Help me out.
18 times what equals what?
Equals 63.
63. Is it 3 or 4?
It's 3 or 4, yeah. Oh, brother. You think it's 4? 18 times 4? When you don't know the answer, you ask a 5th grader. Let's see, 4, that's 32, right? No, that's not going to work. That's 72, so that's too big. So it's a 3 maybe? 18 times 3? That's a 4, that's a 2, that's a 54. So, oh, it's not even. Yuck. Yuck, 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 yuck. Okay, so we know that 9 goes into both of these. So this will be a negative 7 over 2. Eesh, oh well. Gotta live with it. Okay, so y equals negative 7 over 2. So maybe I will go and substitute this back into this one here, because then I've got x equals 3 times negative 7 over 2 plus 13. Does it matter which one I choose? It doesn't. These two are the same equation, just written in different forms. And this is the other equation. I'm sorry, these are the two, these two are the same, just written in different forms. And so then this one, it's where they intersect, so this point will be on this line. So you could choose any of them, but I think this one will be the easier. So this is negative 21 over 2 plus 13. Let's turn this into a something over 2, so how about 26 over 2? Negative 21 plus 26 is 5 over 2. All right, so it's not too bad. So our x-coordinate is 5 halves. Our y-coordinate is negative 7 halves. If you want to write them as proper fractions, that's fine. This is not a slope, so it's okay. We're not writing a ratio. We're writing an actual ordered pair. So that's how this works. All right, enjoy.